Okay, welcome all for this session. During last lecture, we discussed about the strain components. So, starting with this strain component, we have seen the relationship between this epsilon xx, epsilon yy, epsilon zz. So, whatever the outcome we got from the strain components during last lecture, inside which epsilon xx is equal to dou u by dou x. So, in order to achieve this particular equation, whether am I audible?
Yes, sir.
Whether screen is visible?
Yes, sir. Yes, sir.
Okay. That's great. So, during last lecture, we have seen that suppose this is a particular part. So, already here also it is shown that the original position A, B, C, D, which is shown here. A, B, C, D is the original position of any component, and after the deformation it has been changed its shape and it becomes A dash, B double dash, C dash, D double dash, like this. This is the shape changed by the component due to the deformation happened. So A dash, B dash, C dash, D dash is the final position of this particular component here. Is it okay? Then A dash, B dash, C dash, D dash is the shape of the specimen which we have considered. Earlier it was A, B, C, D, and after application of force, the deformation happened, and that deformation, deformed body, small element, small deformed body element is considered to be A dash, B dash, C dash, and D dash. Is it okay? So, likewise, if this is the final shape of this body, then exactly the relation for that purpose we have considered that if u and v is the displacement along x and y direction, which is shown here. This is the u is the displacement along x direction, v is the displacement along y direction. Is it right? And deformation for that purpose, suppose AB is the original size, and which has been changed to A dash, B dash. Then this A dash, B dash, which is shown here. So this is the final length and AB is the initial length. So change in length will be A dash, B dash minus AB. Similarly, here if we see, then AD is the original length and A dash, D dash is the final length, which is shown here. Then A dash, D dash minus AD divided by original length AD will be the we can see it as the strain along y direction. So strain along x direction, strain along y direction. For that purpose, we are referring this AB and A dash B dash, AD and A dash D dash. Is it okay? So likewise, change in length will be measured, considered here, and divided by original length will be considered the strain in x and y direction. Now here, in order to identify whatever the change happened in AB, for that purpose, whatever the mathematical tool we are going to use, that is the partial differential equation, because here u we are considering, u is the displacement along x direction, and for identifying the deformation we are considering dou u by dou x. Is it okay? So dou u by dou x over the length dx, and for vertical direction, it is considered to be dou v by dou y along the length dy. Is it okay? But in order to have this particular distance b dash b double dash or distance d dash d double dash, we are considering the differentiation of v with respect to x, and here differentiation of u with respect to y. Is it okay? So here we can understand this differentiation of u with respect to y, dou u by dou y into dy. And here we can consider that dv, dou v by dou x into dx. So that things we can understand here. We should understand here that why this term dou v by dou x we are considering, because v is considered to be the displacement happening along y direction. So v is the deformation along y direction, but that deformation is the partial differentiation equation is taken along with x for this b dash b double dash, because this b dash b double dash or d dash d double dash is considered as the shear part, and that's why the reference of v is x and reference of u is y here, that we should understand. So last lecture we have seen these particular things, and we are now familiar with this. Is it okay? So with this, we have framed these equations. What is meant by a dash b double dash? What is a dash d double dash? Then what is b dash b double dash d dash? Last lecture we have seen this particular part, is mathematical things here, and finally we got the relation that epsilon xx is equal to dou u by dou x. And similarly, we can say here that epsilon yy will be considered as dou v by dou y, and epsilon zz will be considered as dou w upon dou z. Is it okay? So like this, these three strain components, maybe the strain component in x direction, strain component in y direction, and strain component in z direction, that we can understand here in x, y. Now, one of the important thing which we have to study further part of the strain component, so that we have to continue this time, is the shear strain component. Is it okay? So epsilon xx is the strain along x-axis, epsilon yy is the strain along y-axis, epsilon zz is the strain along z-axis. But what is epsilon xy? So epsilon xy is the shear strain. By considering the reference of x-axis and y-axis, whatever the strain we will get, that strain will be considered as epsilon y. So coming to this figure, we can understand this. So this particular part, b dash a dash b double dash, or d dash a dash d double dash, here also we can consider here d dash a dash. So this d dash a dash d double dash. Similarly, here we can see that a dash b double dash, this part. So addition of these things, b dash a dash b double dash, d dash a dash d double dash, by considering these things, we can get this particular equation here. You can understand epsilon xy is here angle b dash a dash b double dash plus angle d dash a dash d double dash. So this is the shear strain by considering xy here. Is it okay? So here, if we consider this shear strain, then that is equal to here. Suppose if we consider only angle b dash a dash b double dash, or angle b dash a dash d double dash, then by considering this b dash a dash b double dash, here we will consider this as a ratio of b dash b double dash upon a dash b dash. So b dash b double dash upon b dash b double dash upon a dash b dash. So here we can consider this, because here we are considering angle b dash a dash b double dash, we may consider this as a tan theta. This particular angle we will consider as tan theta. Is it okay? So this particular angle we are considering that b dash a dash b double dash plus d dash a dash d double dash. So this angle, always shear strain, for that purpose we are considering this angle as a tan theta. Is it okay? Then this becomes b dash b double dash upon a dash b double dash. So same reference is taken here, b dash b double dash upon a dash b dash. Is it okay? So here also d dash d double dash upon a dash d dash. So here we can understand d dash d double dash upon a dash. Likewise, by referring this particular thing here, we have added these two things. So b dash b double dash upon a dash b dash, d dash d double dash upon a dash d dash. Is it okay? So here we will refer same thing again, and then we will continue the each and every term. We will place each and every term here. So b dash b double dash. What is b dash b double dash? For that purpose, we will refer the equation. So last time we have this particular equation, b dash b double dash. What is b dash b double dash? B dash b double dash, we have framed this particular equation as equation number 3. During last lecture, we have seen that equation b dash b double dash is equation 3, and that is considered to be dou v by dou x into dx. Is it okay? So this equation number 3 you can refer here as the equation b dash b double dash. Is it okay? So what is dou v by dou x? Here you can refer this b dash b double dash, and we will get dou v by dou x into dx. This particular thing we can refer against this b dash b double dash. Is it okay? Similarly, what is d dash d double dash? So for that purpose, once again we will follow the equation number 4, d dash d double dash. So for that, this particular equation number 4 we are going to refer. So d dash d double dash is dou u by dou y into dy. That's equation number 4. And this equation we are going to refer here. So by referring this equation number 4 here, we will get, let us have d dash d double dash is equal to dou u by dou y into dy. So let us refer this equation. So for b dash b double dash, dou v by dou x into dx. For d dash d double dash, dou u by dou y into dy. So these values from equation number 3, this particular value, and from equation number 4, this particular value we have substituted here. Then what is a dash b dash? So for that purpose, a dash b dash, equations which we have framed for a dash b dash. So for that purpose, you just refer a dash b dash is equal to 1 plus epsilon xx dx. So here we can refer this particular equation here. So 1 plus epsilon xx dx. Similarly, a dash b dash for that 1 plus epsilon uyy dy, where exx represents the strain along x direction, and this epsilon yy represents the strain along y direction. Is it okay? So, in simple manner, this equation has been put here. Then what is the value of b dash b double dash? The value of b dash b double dash is dou v by dou x into dx. Value of d dash d double dash is dou u by dou y into dy. Value of a dash b dash is referred to be 1 plus epsilon xx dx, and a dash d dash as a 1 plus epsilon yy upon 1 plus epsilon yy into dy. Is it okay? So we can refer these things here and substitute the values by cancelling the terms. Suppose dx is common, that is cancelled. dy is common, which is cancelled from numerator and denominator here. What we got? Dou v by dou x upon 1 plus epsilon xx. But here we should understand that epsilon xx is equal to dou u by dou x, and epsilon yy is the dou v by dou y. So in next step, a small change has been made here, that epsilon xx, which is replaced by dou u by dou x, and epsilon yy, which is replaced as dou v by dou y. Is it okay? So let us refer epsilon xx and epsilon yy as in individual forms from which we have framed. That is, here we have considered to be epsilon xx is equal to dou u by dou x, and epsilon yy as a dou v by dou y. Is it okay? So let us refer them. Let us substitute them. So after substituting epsilon xx is equal to dou u by dou x, here we will get this particular equation. But here we can understand that whatever may be the epsilon xx and epsilon yy, or dou u by dou x and dou v by dou y, these terms are very, very small. Epsilon xx is the term which is very small. Epsilon yy is the term which is very small. So here, maybe dou u by dou x or maybe dou v by dou x, these are very small terms. So that's why with reference to 1, strain is always 0.001, 0.002. Like this, these are very small terms. As compared to this one value, epsilon xx, if it is 0.001 or 0.002, then it is very small. So that's why this additional part after plus, so that is neglected. So what will this become now? Dou v by dou x, and here divided by 1, because this is very small part neglected. Dou v by dou x upon 1, dou u by dou y upon 1. What it means? It means it has denominator as equal to 1, and that's why by considering denominator as 1, here we can consider them as dou v by dou x, dou v by dou x plus dou u by dou y. Is it okay? So here epsilon xy will be considered to be dou v by dou x plus dou u by dou y. Is it okay? So now we will get all these components here. Already for epsilon xx we have derived the equation to be equal to epsilon xx is dou u by dou x, epsilon yy is equal to dou v by dou y, epsilon zz is equal to dou w by dou z. Now here epsilon xy is equal to dou v by dou x plus dou u by dou y. Then epsilon xz is equal to, similarly, now this particular equation, for that purpose we are using the word similarly, because we have derived only one equation epsilon xy, and with reference to this equation, remaining two equations now we are presenting here by taking concept of similarity. Is it okay? So here if we consider x and y, so the variable along x is u, variable along y is v, then here dou v is considered to be the variable. Is it okay? See, uh, basically by considering this epsilon xy as dou v by dou x and dou u by dou y. So what is the thing common here? V is the variable along y axis and u is the variable along x axis. Is it okay? So dou v by dou x, here terms are opposite. Means differentiation of v with respect to x, and here differentiation of u with respect to y. So this shear strain is considered to be dou v by dou x plus dou u by dou y. Likewise, here if we take the reference of epsilon xz, आता आपण xz चा reference जर इथं आपण घेतला तर epsilon xz, for that z along z direction we are considering variable as a w, and along x direction we are taking variable as a u. Is it okay? So dou w by dou x. So you can understand here the thing, because we are considering strain along xz. So by considering strain along xz, so w is the parameter along z axis and x is considered to be in x direction. So as it is shear strain, always this kind of equations we will have to consider. So this particular equation we are considering with the concept of similarity. Is it okay? So variable along the z axis, it's a differentiation with x, and variable along with x axis, it's a differentiation along with z. Is it okay? So this is particular equation which we get. Similarly, epsilon yz. So for that purpose, the similarity concept we will use here. So variable of y we are considering to be v. So dou v by dou z. So like this we have considered is dou v by dou z. And variable along z direction is dou w. So it is differentiation along with y. So dou w by dou y. So with the concept of similarity, we can consider that epsilon xx, epsilon yy, and epsilon zz. So this was the initial equations which we considered. During last lecture, we have seen this part, that epsilon xx is dou u by dou x, epsilon yy is equal to dou v by dou y, epsilon zz is equal to dou w by dou z. And for shear strain, so that will be, we will consider the strains along the x, y, and z axis. But the strain, which is the part as a shear strain, so for that epsilon xy is equal to dou v by dou x plus dou u by dou y. Epsilon xz is equal to dou w by dou x plus dou u by dou z. Epsilon yz is equal to dou w by dou y plus dou v by dou z. Is it okay? So here the concept of strain component is over. So all three strains along x, y, and z direction, and all three strains which are part of the shear strain, so that is identified. Is it okay? Then let us come to the next type of equation that is considered to be compatibility equation of the strain. Is it okay? So, number of times these two equations are asked alternatively. That means first equation, which during previous lecture we have seen, that was the concept of differential equation. Is it okay? So that was the equilibrium equation, the differential equation or equilibrium equation of stress. Equilibrium equation of the stress हा जो part आहे आपण त्यावेळेस study केला. So at that time the equilibrium equation of the stress was the stress for which we have considered dou sigma x upon dou x plus dou sigma xy upon dou y plus dou sigma xz upon dou z plus capital X is equal to 0. So that kind of equation which was derived, this is considered to be differential equation of the stress. त्याला आपण stress differential equation असं म्हणतो. But for the strain, here once again we will see that, see here, epsilon xx is equal to dou u by dou x, epsilon yy is equal to dou v by dou y. So step by step equations are, numbers are marked here. Epsilon xx is considered to be dou u by dou x. This is equation number 1. Epsilon yy is equal to dou v by dou y. This is considered to be equation 2. Then epsilon xy is considered to be dou v by dou x plus dou u by dou y. So epsilon xy is considered to be dou v by dou x plus dou u by dou y, shear strain. So three kind of equations we are considering here. One is the equation along x, this is another equation along y, and this one is the along equation xy. Okay, so try to understand this. Already we have derived these things, but we have given equation 1, equation 2 and equation 3. Then here we can see the differentiate equation 1 with respect to y 2 times. So step by step process we are going to do here. In order to have the relationship between all the strain components together, which is considered to be compatibility equation of the strain. The compatibility equation of the strain forms the relationship between different strain components. So here we can see that let us differentiate equation 1 with respect to y. So for with respect to y, when it is differentiated, so epsilon xx is considered to be differentiation with respect to y, dou epsilon xx upon dou y. So for that, after differentiating this epsilon xx with this equation, we will get dou epsilon xx upon dou y. That is dou 2u upon dou x2. It will get dou epsilon xx upon dou y, dou 2u by dou x2. And once again differentiating this equation with respect to y, we will get dou 2 epsilon xx upon dou y. So see, understand what steps are followed here. So epsilon xx is equal to dou u by dou x. It is the simple equation which is differentiated with respect to y 2 times. So after differentiating that equation 2 times, we will get 2 times differentiation, that's dou 2 epsilon xx upon dou y2, and this part is also differentiated along y with respect to y 2 times. So it becomes dou 2u upon dou x dou y2, because dou 3, sorry, because initially it is dou u by dou x, which is differentiated. This particular term is differentiated with respect to y 2 times. Then it becomes dou 3u upon dou x dou y2. Is it okay? So try to understand this particular step, that that is getting after differentiating of equation 1 with respect to y, and that again 2 times. Is it okay? So here we got this particular equation, we have given equation number 4 here. So dou 2 epsilon xx upon dou y2 plus, so here is equal to dou 3u, because already dou u term is there, which is after first differentiation it became dou 2u by dou x dou y, and after second differentiation it became dou 3u upon dou x dou y2, which is present here. So this became equation number 4 here. Is it okay? Now let us differentiate equation 2. So this particular is the equation 2. Inside this equation 2, epsilon yy is equal to dou y by dou x. So dou v by dou y. So this equation, already this equation we have framed as epsilon yy is equal to dou v by dou y. So this equation number 2 is again differentiated with respect to x, and that again 2 times. So this term is very important here. What is the return? By differentiating equation 2 with respect to x, and that is again 2 times. So we got dou 2 epsilon yy upon dou x 2. Is it okay? Because after first differentiation it became dou epsilon yy upon dou x, and in second differentiation it becomes dou 2 epsilon yy upon dou x2. Is it okay? So this is the after two differentiations, this particular left term which we will get to the left side. And again towards the right side, if dou v by dou y is the term present at the right side, after first differentiation what we will get? Dou 2v by dou y, dou x dou y. Dou 2v by dou x dou y. And after second differentiation it will become dou 3v by dou y dou x2. Okay, so dou 3v upon dou y dou x2. Here we can understand this thing. So here this equation number 5 is the outcome of differentiation of equation 2 with respect to y 2 times. Here we can understand this equation 4 and equation 5 as this particular part. Is it okay? Then let us differentiate equation this 3 means epsilon xy is given as dou v by dou x plus dou u by dou y. So epsilon xy is dou v by dou x plus dou u by dou y. And this particular equation 3 which is differentiated here. So here what is the message? Just try to understand this message. Differentiate equation 3 with respect to x. So after differentiating this equation 3 with respect to x, what we got? For first differentiation we got dou epsilon xy upon dou x, and what we get? So this particular equation we are differentiating with respect to x. In first differentiation dou 2v by dou x2, and here dou 2u by dou x dou y, because we are differentiating with respect to x, this particular equation. So dou 2v by dou x2 plus dou 2u upon dou x dou y. Is it okay? This is the outcome of this differentiation with respect to x. So epsilon xy dou x is equal to dou 2v upon dou x2 plus dou 2u upon dou x dou y. So this is the first differentiation of this epsilon xy. Same equation is again differentiated with respect to y. So this particular equation is dou epsilon xy dou x, and which is dou 2v upon dou x2 plus dou 2u by dou x dou y. This equation is again differentiated with respect to y. So again differentiating with respect to y, what will be the effect on the left side term? So this will become dou 2 epsilon xy dou x dou y, because we are differentiating with respect to y. In this particular equation we are differentiating with respect to y. Then this will become dou 2 epsilon xy upon dou x dou y. And for this side, right side, what will become? So this will become dou 3v upon dou x2 dou y, and this term will become dou 3u upon dou x dou y2, because this dou y is already present here. So after differentiating with respect to y, this term will be dou y2. For here dou x2 is already present, this will become dou y. So dou 3v upon dou x2 dou y, and dou 3u upon dou x dou y2. So that will be the represented here. So with equation number 6. So here you can write here it as, this is equation number 6, dou epsilon xy upon dou x dou y is equal to dou 3v upon dou x2 dou y plus dou 3u upon dou x dou y2. So this is the equation number 6. Here you can represent this as equation number 6. Then from equation 4, 5 and 6. What is the equation number 4? This is equation number 4 here. What is equation 5? This is equation number 5 here. What is equation 6? This is equation number 6 here. Is it okay? So after referring this equation number 4, 5 and 6. Now what kind of similarities we can get here? You can understand here. It is dou 2 epsilon xy dou x dou y. So for equation number 6, we are going to refer its left hand side. And after referring this left hand side, what we are getting? Dou 2 epsilon xy dou x dou y here. And what is this right hand side? For right hand side, first term, because two terms are present here. Out of these two terms, one term is dou 3v upon dou x2 dou y, and second term is dou 3u upon dou x dou y2. Now let us refer equation 5 and equation 6. Previously we have seen here. So this is dou 3v dou x dou y dou x2. Dou 3v upon dou x dou y2 here. And similarly for this one, for equation 6, whatever the equation we have, 4, for that dou 3u upon dou x dou y2. Okay, so dou 3u upon dou x dou y2. So dou 3u upon dou x dou y2, dou 3u upon dou x dou y2. For that it is become dou 2 epsilon xx dou y2, dou 2u epsilon xx dou y2. So this term is present as a replacement term of this one. So here this one is the replacement part for this particular equation. Is it okay? Similarly, this dou 2 epsilon yy dou x2. Here we can see dou 2 epsilon yy by dou x2 is nothing but dou 3v upon dou y dou x2. So here you can study, you can understand this thing. So these terms are replaced. So dou 3v dou x dou y2 is replaced by dou 2y epsilon yy dou x2. So whatever the final equation we got from all this thing, inside which this is the relationship between shear strain and the strains along x direction and strain along y direction. So this is the relationship between various strain components. Here the reference point is the relationship between different shear components. Dou 2 epsilon xy upon dou x dou y is equal to dou 2 epsilon xx dou y2 plus dou 2 epsilon yy upon dou x2. So here you can understand these things. So this is the relationship between the strain components epsilon xx epsilon yy and the strain component epsilon xy. So epsilon xy being the shear strain component, epsilon xx and epsilon yy being the strain component along x and y axis. So this equation, which represents the relationship between this shear components and component along x and y direction, will be considered to be the compatibility equation of strain. Is it okay? Any difficulties in this discussion? आतापर्यंत हा जो स्ट्रेन कंपोनंटचा पार्ट आपण बघितला, यामध्ये काही डिस्कशन, काही अडचण, यामध्ये काही अडचण आहे का? एनीबडी, एनीथिंग? हा, येस वडगावे. हा,
No any difficulty, sir.
Okay. Anybody, any others? Any difficulty, anything?
No, sir.
Okay. So you understood these things? Strain component part is Understood by all of you? Okay. Now see, similarly, now here one word again we are using similarly. So if we check the similarity of this equation, so already what we are doing always in practical situations, components in X, Y, and Z or three-dimensional object, always the three components are present, X, Y, and Z directions. But for sake of simplicity, always we are identifying the equations because being or establishing the relationship between three-dimensional things, that becomes somewhat complex part. And for this complex part, the equations always be in the difficulty level is always because more number of parameters required to take study and simultaneously this kind of equations formation is difficult. So for sake of simplicity, generally what is considered that any component whenever considered that is considered to be as a plane stress condition, that is only x and y direction, z direction we are always considering to be that is neglected or let we may consider in practical situation if z is less and x and y dimensions are large, we are considering to be plane stress type of equation. So always equations are with two dimensions, means suppose x and y and z, z and x. Like this, we are generating, we are forming zero gap. With same thing, means suppose with this equation that is dou 2 epsilon x y upon dou x dou y. Here, if you consider this x and if this y, then it's a differentiation of this epsilon x y has been carried along x and y. Then dou 2 epsilon x y dou x dou y. So this particular thing which is observed here. Now if we consider the two components, say y and z, suppose here we have considered this y and z. So by considering this y and z, what we get now? The differentiation along y and differentiation along z. Then similarly, so here whatever the equation we have derived as a compatibility equation of the strain by considering two variables x and y direction. Now here same concepts we are going to apply by considering two variables, out of which one variable will be considered to be y, another variable will be considered to be z. So this relation was along xy, so this relation is along yz. So whenever this relation was along xy, we have considered the two times differentiation of epsilon xx and two times of differentiation of epsilon yy. However, this particular equation represents that whenever the shear component is differentiated with respect to x and y, so epsilon xx, that is strain along x-axis, was get differentiated along by y, and strain along y direction was get differentiated with respect to x two times. Is it okay? So same fundamentals we are going to use, we are going to apply for the second set of equation. For that purpose, this dou 2 means if here we are considering to be xy, besides xy we have considered to be yz. Is it okay? So xy was considered epsilon, xy was here. Here we have considered epsilon yz. Then for this yz, the differentiation is carried along y and z. So differentiation of epsilon yz with respect to y and z, we got dou 2 epsilon yz upon dou y dou z. Likewise, this concept here, differentiation of y with respect to z, for that purpose dou 2 epsilon yy dou z2. Similarly, like this. इथं आपण करताना क्रॉस केलं होतं, x चं डिफरन्शिएशन y बरोबर घेतलं होतं, y चं डिफरन्शिएशन x बरोबर घेतलेलं आहे. Likewise, here also we are going to do the same things in order to come to the conclusion and in order to use the same concept for y and z direction. If we try to derive the equation for y and z direction by following same procedure which we have already followed, the final result which we will get, that is the dou 2 epsilon yz upon dou y dou z, which is equal to dou 2 epsilon yy dou z2 plus dou 2 epsilon zz upon dou y2. Is it okay? So here you can consider that differentiation of y that is strain along y-axis with z is considered, and strain along z-axis for that that is considered to be along by with reference to y. Is it okay? So similar concept again applied for this x and z direction. So by using the same concept for the previous equations again used here, what we got, dou to epsilon xz upon dou x dou z is equal to dou to epsilon xx upon dou z2 plus dou to epsilon zz upon dou x2. Is it okay? So try to understand this particular equation here. Dou to epsilon xz upon dou x dou z is equal to dou to epsilon xx upon dou z2 plus dou to epsilon zz upon dou x2. Is it okay? So this particular equation is similar kind of equation as previous equations. Okay. So any difficulty here in this part? या पार्ट मध्ये काही डिफिकल्टी आहे का? एनी डिफिकल्टीज इन दिस पार्ट? या पार्ट मध्ये काही डिफिकल्टीज? Shall we go ahead? Shall we go ahead? Shall we go ahead? Strain component part is over here. हा पार्ट जर लक्षात आला असेल तर पुढे जाऊयात का?
Yes, sir.
Anybody, any difficulties in strain components? These two equations, काही अडचण आहे का? हर्षवर्धन?
Yes, sir. Yes, sir. Clear.
Dinesh? Okay. So
Yes, sir.
let us come to the next part, that is the air stress function. So let us come to one more point related with the Cartesian coordinate system. So already starting with this chapter of Cartesian coordinate system, we have completed starting with the elastic constants. So different elastic constants for that E, mu, Z, K. The relationship between these elastic constants we have established first. Then secondly, starting with this elastic constants, we have seen what is meant by actually equilibrium condition, and with reference to equilibrium conditions, we have identified the unbalance. Is it okay? So the first point through which we started the concepts of starting Cartesian coordinate system, inside which the first point was related with the unbalance. Is it okay? So unbalance in two directions we have identified. Then same equation of the unbalance we applied for this three-dimensional figure, and by applying this equation to three-dimensional figure, what we got? We got the relationship of the equilibrium equation, which is considered to be dou sigma xx upon dou x plus dou sigma xy upon dou y plus dou sigma xz upon dou z plus capital X is equal to 0. This was the considered to be equilibrium equation. Secondly, we identified the equation of the strain component. So various strain component inside that, what is epsilon xx, what is epsilon yy, what is epsilon zz, what is epsilon xy, what is epsilon yz, and what is epsilon xz. And then we identified the relationship between all these strain components. Is it okay? So while identifying the relationship between that strain components, we have used the strain component along shear strain component, then strain component along x-axis, strain component along y-axis. So recently we have established the relationship between different strain components. Is it okay? So that you have seen earlier. Now coming to the most important part of this Cartesian coordinate system, which is considered to be air stress function. Okay. So here try to understand this concept of air stress function as a part of Cartesian coordinate system. There are certain assumptions in theory of elasticity. Always for any modeling technique, for any theoretical case, certain assumptions are there. Whenever any equation is framed, then that equation is based on certain assumptions. And this with that assumptions only that equation is valid. If anybody not considering these particular assumptions, then this equation will not become valid equation with decided parameter for decided parameters. Is it okay? So what is the assumption in theory of elasticity? The same assumptions which we have already carried with our second year subject, analysis of mechanical element or strength of material. Is it okay? काही जणांनी स्ट्रेंथ ऑफ मटेरियल हा सब्जेक्ट त्यांच्यामध्ये लक्षात असेल किंवा काही जणांचं अनालिसिस ऑफ मेकॅनिकल एलिमेंट म्हणून शिकला असेल. But whatever the assumptions were present in strength of material or in analysis of mechanical element, same assumptions we are considering for this theory of elasticity. So what is that? Out of which the first assumption that is considered to be material of stranded body is continuous. Is it okay? So any material, when we consider the continuous type of material, that indicates that there is no any kind of discontinuities. Is it okay? So material is continuous, no any kind of discontinuous in the material. Means there are no any kind of cracks, there are no any kind of flaws, there are no any kind of notches. Is it okay? No any kind of cracks are present, no any kind of flaws are present, no any kind of notches are present, then this kind of material is considered to be continuous material. No any kind of discontinuities are present. Discontinuities as अर्थ material मध्ये काहीतरी flaws present आहे, porosity काहीतरी present आहे, crack आहे, then we will consider the material is discontinuous. But if no such a kind of any cracks are present, no such a kind of any flaws are present, no such a kind of any small notches are present, then it is considered to be material is continuous type of material. Is it okay? Then second assumption is that material of the strain body is homogeneous. So what is the difference between continuous and homogeneous? Is it okay? So homogeneous means for smallest and cut from the body possess same specific physical properties. Means if material is if we consider that tensile strength we are trying to identify, and if tensile strength we are identifying for any particular component of the material, if the size is changed, initially dimensions was larger and second one proportionate dimensions are smaller now. In both the case we will get the same stress or same strength. Is it okay? So same ultimate strength, same yield strength we will get. Maybe the size of the material is larger and size of the material is smaller. In first case, suppose we used 20 mm as cross-sectional diameter, and second case if we used 10 mm as a cross-sectional diameter, but with same proportion if we carry the test, the strength for first case and second case if remains same, then we will consider that material is homogeneous. Is it okay? So smallest element cut from body that possess same specific physical properties, then we will consider the material is homogeneous. Is it okay? So what is the continuous? No porosities, flaws, cracks, etc. present, and if this property of the physical property of the material remains same, then we are considering this as homogeneous. Is it okay? Then third assumption always which we consider in this theory of elasticity or analysis of mechanical element, inside which this is the material is isotropic. What is meant by isotropic? Always iso word when comes, then that represents the direction. Because ortho and iso, these terms we have already studied in engineering graphics. Ortho is perpendicular. Iso is three-dimensional. So ortho is ortho iso. These words are always the words which are considered by considering the directions. So that's why when we consider that material is isotropic, then it means that the properties of the material is same in all directions. Okay. The properties of material is same in all directions. Suppose anybody trying to test for the material in X direction, another Y direction, and third one in Z direction. From all three directions, properties of the material remain same. Then if that properties are remaining same, we will consider that material is isotropic. Is it okay? What is meant by continuous? This is first thing. Second one, what is meant by homogeneous, that is second thing, and what is meant by isotropic, that is third thing. So try to consider these three things and material. So first assumption is material is continuous, second assumption is material homogeneous, and third one is the material is isotropic. Is it okay? So with these three assumptions, these three theory of elasticity, in fact, these three assumptions we are considering. Then the fourth assumption which we consider is material is elastic. Is it okay? Unless and until we are not considering the material as elastic material, then this material, whatever the laws which we consider for theory of elasticity, that will not be followed. Is it okay? What it means? It means that material, whenever force is applied, deformation will happen, and when the force is removed, then material regain its original size and shape, which is considered to be material is elastic type of material. Is it okay? So these are very common assumptions and very basic assumptions in case of materials, out of which material continuous, material homogeneous, material isotropic, and material elastic. Is it okay? So for Airy stress function, again, whatever the function we are going to use, this is always applicable for Cartesian coordinate system, and for that, again, similar kind of assumptions we are taking into consideration. So the Airy stress function is applicable for the material which are elastic in nature. Is it okay? So let us have these assumptions once again. So Airy stress function, for that, same assumptions we are using. And one last assumption which is present in this theory of elasticity is body behaves linearly on stress-strain curve, and displacement involved under load are relatively small. Is it okay? So very small kind of displacements, as well as the strains are always lesser. So this is again one kind of assumption. Now as far as concerned with this Airy stress function, the solution of elastic problem is achieved with the help of Airy stress function, and that is exact method. Okay. So by that way, exactly we are going to calculate, we are able to calculate the values. The stress function is analogous to potential function. Is it okay? So this stress function is analogous to potential function of fluid flow or thermal energy flow or electron flow. So del, this concept already in mathematics we have used, dou 2 upon dou x2 plus dou 2 upon dou y2. This concept is considered to be del function. Is it okay? So del square phi is equal to 0. This is the first thing which Airy stress function states, where phi is considered to be potential function and del is the Laplace operator. So del 2 phi, that means dou 2 with respect to x, and again this x dou 2 dou x2 plus dou 2 dou y2, but function considered is phi. So by considering this will become dou 2 phi dou x2 plus dou 2 phi upon dou y2 is equal to 0. So with reference to this Laplace operator and this potential function, del square phi is equal to 0 is the Airy stress function. Is it okay? So in a stress analysis problem, it is necessary to determine the stress, strain, and displacement as a function of coordinates. If Airy stress function is assessed, then it can be defined as. So already this Airy stress function defines the stress components. Sigma xx is equal to dou 2 phi by dou y2. Sigma yy is equal to dou 2 phi by dou x2. And sigma xy is considered to be dou 2 phi by dou x dou y. Is it okay? So try to understand these concepts of the stresses, sigma xx, sigma yy, and sigma xy. Sigma xx is dou 2 phi by dou y2. Sigma yy is equal to dou 2 phi by dou x2, and sigma xy is equal to minus dou 2 phi by dou x dou y. Is it okay? So with this concept of Airy stress function, we will stop here. For next lecture, we will solve the examples of the Airy stress function. We will try to understand the concept of Airy stress function thoroughly. So with this part, I stop here. So anything, any doubt? Anybody, any doubt? So anybody, any doubt? Whatever the part has been studied, आता जो काही पार्ट आपण बघितला याच्यामध्ये काही डाऊट आहे का कोणाला? Anybody, any doubt? काही डाऊट आहे का? Okay. So let us stop here with this. Please give your attendance.